everyone. In this video, we are going to discuss the solution for find the smallest divisor given a threshold. So let's see the question first and then we will move on to its solution. Right. Alright, so let's study the question first, then we will move on to how we can solve this. Right. So we have been given an array of integer nums. So this is my integer of array. Oh, sorry, array of integer, right? And integer threshold. Yeah, this is my threshold. And we need to choose a positive integer divisor and divide all the array by it, not the array by it, but the element of the array. Okay, and sum the divisions result. Sum the divisions result. What is the result of the division? Quotient. Okay, so instead of this you can say sum of quotient. Okay, okay. Find the smallest divisor. So I need to find the small divisor such that this sum of quotients is less than my threshold. Less than or equal to, sorry. Okay. So each result of division is rounded to nearest integer greater than or equal to element. For example, 7 divided by 3 equal to 3. Meaning that the quotient should be rounded up to the seal value of the quotient. So 7 divided by 3. What is the value? 2.33 something. If we will do the seal, what we'll get? 3. Right. So this is what we need. That's how we are going to find the result of the quotient. Okay. So have you studied the quotient, previous quotient well? Let's find out. Okay. So in that question, what we were doing? We were given Coco was having trouble eating banana, and we need to find the smallest speed for her so that she can eat all the banana in the pile before the guards can come and catch her in the act. Okay. So in that question, okay, let's reference that question later on. Let's try to solve this question now. Okay. So let's say I want to calculate the divisor. So let's start with 0. Let's start with 0. Is division by 0 possible? If you need to find that answer, go and search if you can divide by 0 or not. But I'm going to start my division from 1 because I know division by 0 is not possible. You can try to do that and Java is going to give you error. Alright. Java and C++ and all the other languages. Right? So it doesn't matter what language you choose. This is going to always give you error that division by 0 is not possible. Okay, so let's start with 1. I will start with 1, 1 by 1, 1, 1 by 2, 2 by 1, 1, 5, 9 is for 1. Sum of quotient is equal to 10, 17. So 1 can be my answer. Start with 2, 1 plus 1 plus 3 plus 5. Okay, so 8 and 10. So it's not possible. Let's increase our divisor. So 3, 1, 1 and 1. No, not 1, 2 and 3. Plus equals 5, 7. It is still greater than the threshold. Let's take 4. Okay. 1 plus 1 plus 2 plus 3. Still 7. Let's start with 5. 1 plus 1 plus 1 and plus 2. Okay. So that's it. Add it. We get 5, which is less than threshold. But what we are given? The result of mentioned is less than equal to threshold. So this is less than threshold but not equal to threshold. But is there any integer remaining that can give me the threshold of 6? No, it is not possible. 5 is the only solution here, right? You can see as well in our sample output as well. 5 is the answer for the same array and the same threshold. Okay, so don't complain. Right. Now, if you look closely, what we are doing, we are trying to search one number among infinite numbers. We are starting from 1 and we will go till infinity. Let's write it here. 1 dot 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 infinity. We are doing something like this. We are searching something and we are going one by one towards a greater value. Isn't it the linear search algorithm? If we can use linear search algorithm, can't we use binary search here? So we can use binary search. But won't it be idiotic to start from 1 to infinity and then calculate middle and then try to search? It's going to take a very long time because value for infinity is not defined. Infinity means very big value, right? This is not going to give me a very efficient solution. This is going to take much more than anything. It's going to take actually more time than what you can say infinite. Not trying to find middle for the infinite value is actually possible, but we are not going to do that here. We need to reduce time as much as possible. So instead of going for infinity, we will try to find something related to my array. If I use the maximum value from here, isn't it possible to find the smallest divisor after this? Because at minimum, this will give me these values: quotient 1, quotient 1, quotient 1, and quotient 1. And minimum threshold will be 4. And even if I raise to 10, this is going to give me same result. 11, also same result. So instead of going till infinity, I will start with 9. Right? If you have watched the previous video, don't you think we are doing the same thing here that we did in the cocoa eating banana question? Yeah, we are doing same thing. First, we are finding the highest element, which is nothing but 9. Now we are going to apply binary search. From 1 to 9, let's apply binary search. Mid is 5. And we are going to check the sum of quotient made by 5. 1 plus 1 plus 1 plus 1 plus 1. Not 1, 2. And I have 5. So 5 could be my possible divisor. Okay. Now, what we were doing in that question, if we find a possible value, then what we were doing, we were trying to reduce this value. So now we are going to check from 1 till mid minus 1, which is between 1 to 4. Mid is 2. Actually, it's 2.5, but we will take 2. Right? So let's calculate with 2. 1 plus 1 plus 3 plus 5. 8, 9. It's very big. We need to reduce it. And to reduce it, what we need to do? We need to increase our mid. To reduce this, we need to increase our mid. You understand what I'm saying? So what we need to do is, we need to search in between 3 and 4. 3 and 4. Mid is going to be 3. let's compute it with 3. Now what we are going to get? 1 plus 1 plus 2 plus 3. But we are going to get 5, 6, 7. Still more than that. So now I need to increase my low again to mid plus 1. Mid was 3. So now my low value and high value will overlap over 4. Now I'm going to check for 4 because low and high equal same. So mid is also going to be the 4. So 1 plus 1 plus 2 plus 3, 5, 6, 7. 7 again, which is more. So we need to increase our low and higher. We need to search our area, but we are overlapping already. If we are going to increase our low, my low will become 5 and high will remain 4. But if you will remember in the binary search, we just stopped in this condition. We were searching only for this condition. Low is less than equal to high. Now low has become 5 and high is 4. So we are not going to search anymore. And there was only one possible solution which was not updating. So I am going to return this 5. So that was a very pretty simple question. And if you have watched the previous question, you will find that we have done exactly the same thing in that question. In place of this array, I had files array which was storing the number of banana in each file. Okay, and instead of threshold, I had number of R, which was denoting the number of R's for which the guards are gone. And I was trying to find some speed so that Coco can eat all the banana at a very slow pace so that she can enjoy eating those bananas. And as we discussed earlier, she was a banana lover. So she actually wants to eat banana at very slow pace. So we need to decrease the speed as much as possible, but letting her eat all the bananas. Alright. So we are doing the same thing here, and when I will code, you will actually understand why I said this. And if you haven't watched that video, after I have written the code, I will actually suggest you to go and watch it. Okay, and why I will do that, I will tell you in the coding part. So let's start the coding part now. Okay, so let's write that code. Right. So what we were doing was, first of all, we were trying to calculate our max. So let's name it mx, and let's say it is starting from 0. Okay. Now for int le, for each loop for my num, right? And what I need to do in this is compare my current this max with my element. So math dot max mx comma nums I, not nums I, le. Okay, so that's it. I found my maximum element. Now low equals 1, because if I use 0, it won't make any sense because we can't divide by 0. But math says that, I don't say this. Okay, it's not possible to divide by 0. If you want to divide by 0, you can try it. Java is going to give you error. Okay, so I is equal to max, and what I was finding was divisor, right? So divisor, let's say equal to 0. Well, it doesn't matter even if I start my divisor from 0, because divisor 0 is not going to give me any trouble. Okay, because my while loop will always run and it's going to change the value here. Okay, so while low less than equal to I, first thing in the while loop, what we were doing, we were calculating a mid divisor, or just mid. Now low plus high divided by 2. If you have watched my previous video, you will find that this should not be the correct statement here, because this is going to give me a trouble, which is called overflow. Now what this overflow is, it is nothing but if my high is equal to integer dot max value and I'm trying to add something to it, even 1 to it, so my high is going to overflow by the integer that we have already defined as the 4-byte value. It's going to exceed that 4-byte and my number will overflow. High integer is going to be overflowed. So I told you in the last video how we are going to resolve it. We are just going to use this high minus low, and like this we resolved our overflow problem, right? Now we need to check if the mid divisor that we have found, is it possible? What is possible? Possible to have the sum of the quotient made by this mid divisor less than or equal to my threshold. So we are doing some abstraction, saying that this function is going to tell me how is it possible to have that mid or not. So I need to pass the array and the mid so that it can calculate the value for the sum of the quotients, right? And it's going to check it with the threshold. If the sum of quotient made by this mid divisor is less than or equal to threshold, then it is going to give me true, else it is going to give me false. How it is going to work, we are going to define that function later on, right? So let's start here. Let's just focus first here, then we will see how this function is going to work. Now if let's say it is possible to do that, the first thing we are going to do is we are going to set our divisor to the value of mid, right? And after this is the possible value. There could be a value that is less than my mid, which can give me even less answer, or the minimum answer, or the minimum solution for the same problem. But so we are going to check on the left side from the mid. So I need to change my high to mid minus 1, and that's it. And now else case, else if this is not the case, I haven't found anything in this area, then I have to shift my searching area to left side. So I need to not left side, right side, sorry. So for that I need to do low equal mid plus 1, right? And after this, what I'm going to return, I just need to return the divisor. That's it. We are done with this code. Now we need is this. I need to write this is possible function, and after this we are done with this solution, right? Now it's going to return me what? A boolean value, right? Boolean value, and array of integer, mid is int, and threshold is also an integer. Now here I am going to calculate the sum of quotients first. So let's start it with 0. I'm going to write the for each loop the same way. So let's copy paste it. Yeah, this is my for loop, because I'm going to iterate over my array again to calculate the sum. Sum plus equals math.seal. And why seal? I have already discussed that in this question we are taking the seal value after dividing our element with mid or the divisor. Okay, so LE 1.0, and why we are multiplying it 1.0? Because our both elements and the integer in the array and the mid that we have taken is in int, and we need to convert it into double so that we can have some seal value. Otherwise this is going to give me the value when we divide by integer. Okay, so divide by mid, and that's it. Okay, now we are going to check if some of these quotients is less than equal to threshold. If this is true, then I need to return true, else I need to return false. So that's it. Let's run it. Right, it's passing for my sample test case, and it passed all the test cases. Of course it's going to pass because I read in the correct code. All right, now let's discuss this solution with the solution that we have made for cocoa eating banana. Look carefully. This, this, this. Don't it seem very similar to that solution? Okay, if you haven't watched that video, I will say to go and watch it and see the solution that I have written, and you will find very much similarity there. In this question, I have just changed this. In cocoa eating banana, instead of using num, I was using piles. In place of mid, I was using speed. In place of threshold, I was using number of hours. The guards were gone. Right. Go and check both this code and that code, and you will find that I had just changed only these three variable names and nothing else. I just changed the variable name, nothing else, not even a semicolon. Okay, semicolon are important, right? Maybe I haven't used brackets. Okay, so that's it. Now let's talk about its time complexity. This was going to take n time, this is going to take n time, and this is going to take n log n time. And why n log n time? My log n function, log n loop is calling a function with time complexity of n, so n log n. So overall my time complexity is going to be n log n. Have I used any additional space? No, I haven't used any additional space. This is a constant space solution. So that's all for this question. If you will look line by line this question to the solution of cocoa eating banana, you will find that everything is actually same. Just three things: piles, speed, and R. Variable names are different, but the concept and the running of code is entirely same, and not even anything changed. Anything. Just the name of variables have changed. So it means that the concept is all you need to solve any problem, because all the concepts are going to be used somewhere or another if you will look hard enough. Okay, like here you can see that I have used the concept of finite search in here. And why binary search is used? Binary search is used to find something very efficiently or very fastly as compared to a linear search. We have used the concept of binary search in this question, where it was not possible to think like that, but I think now you are able to think much more better. Okay, so that's all for this video, and I hope that if you haven't attempted the cocoa eating banana problem till now, you will try to attempt it now, and now you know the solution for that also.